Right, 4.4, Pascal's triangle. So we're going to be stepping away a little bit from permutations and looking at Pascal's triangle. May at first seem kind of odd why we're doing this, but it does make sense in that still we're counting numbers, but in a slightly different way. So Pascal's triangle, as it says, is an array of numbers with many different properties and series of numbers. Mathematicians can spend their whole lifetime just looking at Pascal's triangle and find different patterns for different situations. You can also find many instances of Pascal's triangle in nature, looking at the number of seeds on a pine cone, the number of petals or seeds on a sunflower. If you start from the middle and work your way out, petals on a flower, stems on a plant. Those are just some. There's many, many more. Okay, so how does Pascal's triangle work? So the values in Pascal's triangle start with 1, and then you go down next row. It starts with 1, ends with 1. So each row starts and ends with 1. Okay. We can use terms to represent the numbers. Okay. T sub n sub r. N is the number of the row, and r is the position in the row. Make sure that you remember that both n and r start with 0. So this position here is row 0, 0. This would be position t, or term 1, 0, and term 1, 1, and so on and so forth. Okay, you can see that numbers do get quite large as you get further down. Again, working with our big numbers. Here we are using the terms in Pascal's triangle. You can see that this is the first row, second row, third row. You can see how the term numbers work. If we go back for a second, you also note that if we add these two numbers, we get this number here. So 1 plus 1 is 2. And if we look at this row, row 2 compared to row 3, we get 1 plus 2 is 3, and 2 plus 1 is 3. And we can continue on that all the way down through Pascal's triangle infinitely. This works with this formula here. Tn r equals Tn minus 1, r minus 1, plus Tn minus 1, r. Basically, in words, take the two terms above any term, add them together, and that will give you the next term. Obviously, except for the two n terms, which are always 1 when we're dealing with Pascal's triangle. So there's many different hidden ideas within Pascal's triangle. In class, we'll look a little bit more at these. I'm just going to show you one. Okay, so here is the sum of some of the rows. Okay, so if I took the terms and added them up, so 1 plus 1 is 2. Row 2 is 1, 3, 1, or sorry, 1, 2, 1. So 1 plus 2 plus 1 is 4. Row 3 is 1, 3, 3, 6, 1. So 1 plus 3 plus 3 plus 1 is 8, and so forth. So hopefully you can start seeing a pattern. Take a second, think about what the pattern might be. Okay, so the sum of the entries in the nth row of Pascal's triangle is equal to the power of n. You want to work for the first one, since it's row 0, 2 of the 0 is 1, and there's only one value. Again, a short little lesson. Try these questions, and we'll see you tomorrow to explore Pascal's triangle a little bit more.